Here in example 3, we're going to work on factoring with different patterns, and then we'll try to simplify if possible. For the first pattern on example 3a, I noticed the difference of squares pattern because of square root of secant, square root of secant. Square root of 1 is 1, and so that makes secant of theta plus 1, secant of theta minus 1 for the final answer on A. For part B, a little more challenging. This looks like an A times C type of problem. And so to factor this, one thing I like to do is take out tangent squared and tangent, just put an x. So make it 4x squared plus x minus 3. If I do the A times C pattern, A times C makes negative 12. Factors of negative 12 that add up to make 1 are negative 4 and 3. Or excuse me, actually it should be positive 4 and negative 3. Divide them both by A. That makes 1. And so you'd have x plus 1 and 4x minus 3. If there's a different strategy for factoring you like to do, go ahead, but you should get the same answer. And so this factor is now, instead of x, it's going to be tangent of theta plus 1. Took out the x, back with tangent of theta. And 4 tangent of theta minus 3 is how that factors. See if you can figure out number 45. I would start with common factor for cotangent squared x, by the way. Okay, now that you've had a chance to figure it out, the common factor is cotangent squared x. So I'm going to put cotangent squared x on the outside parentheses. Those cancel to make 1. Those cancel to make minus cosine squared x. This should look familiar, 1 minus cosine squared x, because that is sine squared minus cosine squared equals 1. Sorry, plus cosine squared. But if I subtract the cosine squared from both sides, I get sine squared equals 1 minus cosine squared. So I'm going to take that out and put in sine squared in its place of x and cotangent squared of x. Next thing I know is that cotangent squared of x is equal to cosine squared over sine squared. And that is on your formula reference sheet, so cross that out. And that becomes cosine squared x over sine squared x times this sine squared x that we had from before. Those cancel, leaving the final answer of cosine squared x after I factored that.